So again, the old term, data abstraction. By this time we know the meaning of data abstraction. That is, hiding the complexity of internal representation. Now, DBMS provides abstract view of data. See, at the core of the thing, there is a physical level definition of the database. On top of that, we have the conceptual or logical level definition. And then we have the view level definition. Rather, I should say, there may be multiple views. Say view 1, view 2. So this way there will be number of views. So at the physical level, it deals with how data is stored. At the conceptual or logical level, we are bothered about what data is stored. At the view level, part of the data available to a user that forms the view for the user. So different users may have the different view of the database. Suppose we are storing the records in the file, say our struct. So we are storing the student information. Say struct student. We have a record structure like this. Then say, okay, it's like this. So one can say at the physical level, the record say, if we immediately say, if we assume 2 bytes, so 2 plus 31 plus 10. So there is a 43 bytes, of which first 2 bytes represents an integer. Next 31 bytes represent a string. Again, then there are 5 integers. So physically it is stored like that. Logically we say the record consists of role, name, and 5 marks. So what data is stored? No, not how. 2 byte, that 1 byte, an array, each element is of 2 byte, representing integer, etc. So those are the physical level kind of thing. This is the conceptually the record is having role name and 5 marks. Now, if it is a collection of all the students, then again remember, if it is the HOD CSE is looking a part of the data belonging to the CSE department. HOD VGC is looking into the VGC part. So there may be multiple views. The part of the database which is made available to a particular user, that may be the view of that particular user. So see, it is abstracted where is the file, how the thing is getting stored, etc. etc. We are not bothered. Mostly, whenever we will be dealing with the database, we will be dealing at this logical level and the view level. That's all. We won't go into the physical level definition. So that is the most complex part. How internally it is being handled. So it talks about the internal representation. Mostly we will be dealing at the conceptual level and the view level. Data model. There is the concept of data model underlying the structure of a database. So the structure of the database is based on nothing but certain data model. Now, this data model this is the collection of conceptual tools to describe the data their interrelationship data semantics, the meaning associated with the data, and constraints. So that means in a data model, we can, through the data model, we can represent the data description, their relationship, association kind of thing. We can go for interpreting the data and the constraints on the data. So based on these, we can go for defining the structure of the database. Now, these data model may be categorized in various ways. We will be focusing on record-based model. So as if the database is collection of files, and a file is collection of records. So we are also habitually thinking in that manner whenever we have worked with the high level languages. We have considered, say, student is a file, result is a file, subject is a file, faculty is a file. In the files we have so many records, etc. etc. Now, this record-based model we can further categorize as relational model network model, and hierarchical model. Suppose we want to store the department information and the student information, and there is a relation, say student studies in a department or students admitted in a department. So we may consider a file for the department where every record has a department code, department name, and other information. Say CSC is the department code, department name, say computer science and engineering, and other information. Say ETC is the code, electronics and telecom, like this. So these are the records. So as if every record has a department code, a department name, and other information. Similarly, so for every department we have a record. Similarly, for the student also we may consider say role, name, date of birth, other informations. Say role 1, name, AC, etc., etc. So for every student, there is a record. Now, there is a relation between this student and the department. We know that student studies or admitted in a department. So how to keep that information? But this kind of issue we have addressed already whenever we have done for object-oriented programming in designing the models. So see, one method that we have often followed, see, assume every department has a unique department code. So as a student studies in one department, so if we keep that particular attribute as a part of the record, say new CSC, CSC, ETC, like this. Say I'm not considering this is role, say this is registration number. You have those long registration number unique. So if it is like this, then see how we are maintaining the association. To maintain the association between these two types of elements, as a part of the record, we are adding a field. As a part of the record, we are adding a field. Based on the value of that particular field, we will find the relationship, find the related one in the other set. So this is relational model. We are just briefly introducing the relational model. Mathematical formalism and all those things we will be discussing later. So in a relational model, to establish the relation between two types of records. As a part of the record, a common attribute is kept based on the value of that attribute association is maintained. So if I want to find out the department information for a particular registration number for a particular student, so given the registration number, I can find out the value of the attribute, then I can search here which one is the record for that particular value, say CSE, and I can find out the corresponding department information. So the association or the relationship between them is maintained by keeping one common attribute as a part of the record. So we have the value of that common attribute that will help us to get the association. That is the basic thing of the relational model. Now, if we think about network model, if we think about the network model, instead of keeping the value of common attribute in the record, a pointer or link to the related record is kept. So earlier it was the attribute value. Now see, here as a part of the record, it will not keep the common attribute value. Rather, it will keep a pointer. Say if it is belonging to CSE, it will keep a pointer pointing to the CSE record. It will keep a pointer pointing to the CSE record. If it is belonging to ETC, it will keep a pointer pointing to the ETC record. Right? So, what are the pros and cons of this network model? See, if I say find the department record, for a student, so given the registration number, we have the pointer. So directly I can go to a particular record of that particular file. Now you may say that normally pointer we talk about the memory value. So here whenever we are saying the pointer, what does it mean? We can keep the block address. We can keep the block address in which block my secondary storage is record is stored. Then whenever I want to find out the particular record, see with the secondary storage, the unit of transfer is the block. So if I know the block address, this block address, then simply it will read that particular block. Otherwise, in the earlier case, if the file is consisting of say 100 blocks, then in the worst case we have to go for reading all the 100 blocks to find out that particular record. Now, in this case, as I know the block address, the block number, so directly we can go to the particular block, and only that block has to be read. So number of block accesses that is getting drastically reduced. So that is the advantage, that if I am trying to find out the particular related record, then getting that one is easier, as I have the link, I have the pointer, I have the block address. So we know which block in my disk will be reading this the corresponding record. Done. That is the advantage. So advantage is that finding the related record based on the link is faster. But see, because of insertion, deletion, modification, or say the growth of the particular file, if the records are relocated, then whole thing has to be changed here. So if blocks are relocated, maybe due to expansion of the file, expansion or so, all links to be changed. Right? In the earlier case, if it is relational model, it is not bothered about the physical location. It has copied only the value of the department code. So even if these are shifted to some other places, that will have no impact. Right? So for a very typical kind of case, one can go for network model. But see, the most popular one is the relational model. We will be dealing with the relational model. If we think about say Oracle or DB2, the standard databases that are available commercially, those are based on this relational model. Now, another scenario may occur. Say there are different types of entities of related entities. So there will be number of files. So maybe that this is one type of entity, another type of entity, another type of entity. So it is linked with this one, this is also linked with this one, this is with this one, this is with this one, etc. etc. Again, this may be with this one, also with this one, like that. So the network model, it may give rise to links in different files, may give rise to a forest. So this is a complex and unorganized. Now there is the hierarchical model that is similar to the network model, only difference is that those are organized according to a hierarchy. So basically, the network model is organized as I feel. Its organized version is hierarchical model. In both the cases, to maintain association between the records, pointer or link is kept in records, kept as a part of records, not the value of attribute. But here, records are organized according to certain hierarchy. Say we have various department records, say CSC, etc., etc., etc. So this is at one level. Maybe that it is having links to say UG1, another link say to UG2. Similarly, for others, same thing here also. Then it is having the links to the individual student record. Say roll 1, roll 2, like this. So now they have been placed according to a particular hierarchy. Now if I know that in my database, mostly I will be accessing the data as per that hierarchy. It is more or less a fixed kind of pattern. Then see, it is very useful. So this is and these are seldom used, only in case where it is very specific kind of scenario, where I want to develop an application where the data will be accessed always according to certain hierarchy. So that time, if the data is organized according to that hierarchy, then obviously it will be beneficial. But obviously, if I need according to a different kind of hierarchy, then all the time it may not be helpful. And in general, if the records are moved, relocated, then all the links have to be updated. Otherwise, you will have no use. So those are the fundamental differences between the relational model, network model, and hierarchical model. Henceforth, we will be focusing on the relational model. Two terms we must be clear about this: instance and scheme, or sometimes we say schema of a database. Schema of a database or scheme of a database, it specifies the overall structure of the database. Say a student database, it is consisting of role as integer, name as say string, say date of birth, say if I consider date as a type, etc., etc. So what will be the structure of the database? That is the records. So as if the student database, the structure is that it will have role which is of type integer, name which is of type string, date of birth, say of type date, etc., etc. So what are the different attributes and their types? That's the schema, the structure of the database. Instance means content of the database at a point of time. At a point of time. Because we may add data or we may add records, say, or we may modify certain data, or we may delete the record. We may carry out these operations at different point of time. So content gets changed. So that's why at time instance T1, there was a particular instance, say instance T1, and at time point T2, instance T2, they may not be same. If we add record or if we modify certain data or delete certain record, then the instance is getting changed. So it changes frequently with time. On the other hand, see the schema. Schema also can be modified. We may find that, okay, we need some other attribute, whether say continuing or not, readmitted or not. Say earlier we have not considered, we may decide, okay, for our processing, this is essential, so we may add certain this kind of attribute. So schema also can be modified, or we may change the size. We consider, okay, roll number, say this is the integer, we find that in our case the roll number is quite large. May not be feasible to store everything as a simple integer. We may consider some long kind of thing. Or say score. We have considered score as integer. Later we found that no. Sometimes we may have to decide on the fractional part also. So keeping only the integer is not good enough. So we may make these things real. So that kind of changes may occur. So schema also can be modified. But this is infrequent. This is infrequent. Every now and then, if I go for changing the schema, changing the structure, that means the design, we have not designed it properly. So every day you will be changing your structure. Right? So this change is more or less infrequent, but this change in the instance, that is much more frequent. So this is more or less a static kind of thing, but this is highly dynamic. The content may be updated time to time. Data independence. Already you have seen that we have the physical level definition. On top of that, we have the conceptual level, then the view level. So this is the lowest level. This is the highest level. This is the intermediate level. Data independence. It talks about capability of modifying the definition at a level without affecting the higher level. This is the basic meaning of data independence. That means if I change at this particular level, it will not bear any impact of this. If we exclude this, what does it mean? That without affecting the higher level definition. See, we'll be developing certain application. We'll be developing the certain application based on the definition. We'll say Physical level definition independence is achieved if change in the physical level definition doesn't have any impact on the application program code. Forget about database. Suppose, think about any of the collection classes or the STLs. Think about the STLs. Suppose we are searching or we are traversing all the elements in a collection. Whether that collection is array or linked list or something else, if I go by the iterator, if it is a sequential container kind of thing, if I go by the iterator, that begin and end, implementing this, whether this is an array or vector or linked list, it doesn't matter. That is the physical level definition. Based on that, I have written the code to traverse all the things. There the program will not be changed, even if this array becomes linked list kind of thing. So here, if we can change the physical level definition, but the application program code that remains unaffected, no change has to remain, then we can say that, okay, we have achieved the physical level definition independence. That is, it is independent of the physical level definition. So similarly, one can say that conceptual level definition independence. When so it means it is achieved only when conceptual definition change, but no change in application program. Obviously, this is difficult to achieve. This is difficult to achieve. Say, if I'm having, say, roll name and marks of the students, I want to perform some analysis based on the marks. Now, the video show that the marks, that part is not present. Then obviously I cannot work with the marks. Now, whether that marks is an array or linked list, that is the physical level. So I can achieve independence of that implementation. But if that particular conceptual level is changed, then possibly that will be pretty difficult. But this physical level independence, that is achievable. Whenever we are writing, we will be